In the previous lecture, we have studied about the receivers of amplitude modulation and the direct and indirect FM generations and PM generation method. Now we will continue with the next chapter, which is about the pulse modulation and demodulation. The beginning of this chapter will be with the important concept of the sampling, and we are going to concentrate a sampling of a low pass signal, and that low pass signal we are going to consider a band limited signal which will be looking something like this. So there is some signal which is denoted by j of omega, whose frequency is band limited from minus omega m to omega m, and therefore this particular signal is called as band limited signal. Now when we talk about the continuous time signal or the analog signal versus digital signal, the digital signals are always having the advantage, the digital systems are always having advantage, and we are having all the systems nowadays which are nothing but working on digital process, digital system. The advantage of the digital signal over analog is the digital signals will have a flexibility of simply changing the program. The digital signals are easy to store, it has highest accuracy, and digital signal will be always be able to apply the highly sophisticated algorithms to modify the process. The disadvantage of the digital signals are it has certain limitation, that very fast sample rate is needed when the bandwidth of the signal is very large, and it has a larger time delay as compared to the analog signal. So in the pulse modulation chapter, we are not going to fully talk about the digital system, but we will understand in this chapter that how to convert the analog signal into digital, and then what are the steps involved in converting analog signal to digital. So here you can see the diagram in which on the left hand side analog signal is shown, and on the right hand side the sampled version of it is shown. So this particular diagram is not exactly analog to digital converter, but this diagram is showing you the first step of converting analog signal to digital. In my upcoming videos, I am going to explain in detail that how the analog signal is converted to digital, but sampling is the very first stage of converting analog signal to digital. So we are going to highlight three different types of sampling. One is called as impulse sampling, second is called as natural sampling, and third is called as flat top sampling. So this is the diagram for the impulse sampling. There is a continuous time signal x of t. These are the impulses which are having a duration of ts second. So you are having 0, then ts, 2ts, then on the minus ts, minus twice ts. And sampling means what? You are simply multiplying the sampling signal and the analog signal, and therefore when you are multiplying these two signals, the output you will be getting is this. So since you are multiplying the analog signal with the impulses, this particular kind of sampling is called as impulse sampling. So our output y of t will be equal to x of t into impulse train. If you have studied the definition of impulses, then impulses will be written in this form, that is summation of n is equal to minus infinity to infinity del of t minus nt. So if you substitute n is equal to 0, then you will get first impulse at del of t, that is this one. When you substitute n is equal to 1, it will be at ts. When you substitute n is equal to 2, it will be minus ts, and so on. And when you convert frequency domain by taking the Fourier transform, the equation will be looking like this. So this is the process of impulse sampling, wherein our sampling signal is the impulse train. The second type of sampling is called as natural sampling, wherein there is a pulse train, but that pulse train is having some period. So our now analog signal is going to be multiplied with the impulse train, okay, and this particular will be having some period of t. So x of t multiplied by pulse train will give you y of t, and this is called as natural sampling. So you can see the sample. So analog signal is converted to sample, and these are the samples which are placed at the regular interval, and this frequency at the output will be definitely depends on the sampling frequency. We are going to see in detail what is the role of sampling frequency in sampling the analog signal. The third type of sampling is the flat top sampling. Flat top sampling may you have same impulse train which you are multiplying, but only the difference here is you are having some holding device connected into your circuit, into your system, and because of that, whatever output which you are getting, whose tops are going to be flat. You can compare this flat top sampling and natural sampling. See, natural sampling has the same shape of the sine wave, but flat top sampling has a top which are flat, and this is happening because of some holding device which is working into the circuitry. So this particular type of sampling is called as flat top sampling, where the tops of the signal are flat. So here is some comparison between the natural and flat top sampling. The natural sampling and flat top sampling. Ideal sampling is just a multiplication process. Natural sampling is going to chop your waveform, and flat top sampling will have some kind of sample and hold device into it, and these are the waveforms for the natural and flat top sampling. The next lecture, we will be able to discuss in detail that how the sampling process is carried out and what rules, what law, what theorem has to be followed, and that is called as sampling theorem.